everyone, just a quick update on my coding game playlist. I've added my explanation code throughout most of my puzzles, so if you want to check that out, you can see on the description below. And from now on, depending on the puzzle, I will either explain my code in detail, either in this video, or I will explain it in the description. So do check it out. Okay, let's start the puzzle. Benford'S Law. In this puzzle that shows a real-life phenomenon, you have to detect whether a bank account have a high risk to contain fraudulent transactions. The Benford Law is used on real anti-fraud systems to detect frauds about government accounting fraud, fiscal fraud, or even election cheating. If you want to check out more about Benford'S Law, this is the website to check it. I will also leave that in the description. Your program receives an input, a list of transactions like 1122.85 minus 10.69 minus 21.79 plus 12.08. All of it in dollars. You have to count how much transactions start with 1, 2, etc. For example, plus 1122.85 starts with 1. Minus 0.50 starts with 5. And $242 starts with 2. And you must output true if the bank account seems fraudulent, or false if it seems regular. For this puzzle, your program will navigate output whether a bank account seems fraudulent or not. You will be given the Benford'S Law percentage. The first one is 30.1%, second one is 17.6%, third one is 12.5%, fourth one is 9.7%, fifth one is 7.9%, the sixth one is 6.7%, the seventh one is 5.8%, the eighth one is 5.1%, and the ninth one is 4.6%. An account is considered regular if the account starting numbers percentage follow this percentage with a margin of 10%, which means that you may find transactions starting with 30.1%, so between 20.1% and 40.1%, transactions starting with 2, 17.6%, so between 0.6% and 27.6%. If at least one of these percentage is outside the expected range, the account is considered as fraudulent. You must then output true. Note that transactions may be formatted like this. It can be any currency. Okay, it can be any currency. So, that's my fault. I'm gonna use Python for this episode. So the first line is the number of transactions, which is n, and the for loop is the transactions can be formatted like this. And for output is one line true if the account seems fraudulent, false if it seems regular. The constraints is 0 less than n is less than equal to 1000. So, for example, if all of these, I'm not gonna check all of that. If all of these are transactions, then the output will be false. So there's 6 test cases. The first one is regular account. The second one is fake account. Lots of numbers starting with 1. The third one is fake account. I'm not gonna pronounce that word. Fourth one is adjusted account. Fifth one is regular lesser transactions, and the sixth one is fake account. Again, I'm not gonna pronounce that word. So let's start the puzzle. Right. Did I say I'm not gonna pronounce that puzzle? I apologize. I'm not gonna pronounce that word. Alright, let's start. Okay, let's explain. Alright, okay, let's explain this code. So the code starts by creating a list B. Right, so the code starts by creating a list B which contains some values. Then an empty dictionary V is created. Next, the code takes an integer input n from the user, which is used in the following for loop. Just right here. Actually, control of this. So in each iteration of the loop, the code takes a string input from the user. It extracts a digit from it and stores it in the variable NMB. The dictionary V is updated to keep track of the count of each digit. Finally, the code checks if a certain condition is met. It uses a list comprehension to check it for each digit I in the dictionary. V, the count of that digit, divided by n, the total number of inputs, multiplied by 100, falls within a certain range of values. If this condition is met for all digits, the code prints false, otherwise it prints true. And that's how I solved this puzzle.